I'm Scott Wardle, and I'm going to talk to you about EA's secret weapon, packages and modules. But before I do, I have some kind of bad news. Igor Maslov, who's a coworker of mine, he ended up dying recently. He was kind of the go-to guy at EA for packages for quite some time. He was, reviewing this presentation. That's the last time I saw him, and so hopefully I live up to his expectations. Anyways. But who am I again? As I said, I'm Scott Wardle. I'm a senior software engineer with EA. I've been working on FIFA for a long time, and been over 20 years in games. Mostly I'm known for systems programming, and what I mean by systems programming is making things technically better, the best type of better. So something measurable, changing frame rates or affecting build times or less memory, less space on disk, some kind of measurable, technical achievement. Obviously, then we have to discuss with the team itself and figure out what does technically better mean, and I write metrics for that type of thing as well. So memory monitoring, that sort of stuff, but that's not really what this talk is about. This talk is about the other questions I get, which is, okay, I want to make things technically better, but I don't know how to measure it. Things like, I want to share more, or engineering, I want them to be faster and more productive. These things, I don't really know how to measure. And if I talked about those things at CppCon, then everybody seems to talk about modules here. They sound like magic, and they're going to fix all of the things everywhere, and so I wanted to look into them and try to understand what they were, because I didn't really understand them, so, meh. One thing I did understand is they were attempting to fix build times, and so this is nice. This is easy to measure stuff. You can, just run it, and if it goes faster, great. As I said, I'm not going to talk about that kind of thing too much. Other people have talked about it. What was more interesting to me is things like bad interfaces and things that are hard to share. Can this improve that, and how is that going to work? I don't know. The other thing was that everybody seems to really want this stuff as soon as possible from beyond Blizzard. This is obviously very, very popular. But we sort of already had some technology at EA that really helped us with a lot of these things. It was kind of the secret weapon I've always sort of relied on at EA. I can take a package from anywhere in our company and I can build it, and it just works. Get this. This is the technology we have. We take a bunch of C++ code and we turn it into a library. I know, shocking. It's a build system, and everybody hates build systems, and yeah, most people at EA even hate ours, so, it's what it is. But I really do think it gives us an unmeasurable advantage, being able to take source code quickly from any team and actually get it to work. But modules aren't that. So modules are about the new way of interfacing into maybe a package or a library of technology. They're sort of an interface bit. They're smaller unit, and so they're not quite the same thing. But at first, I was not really so sure. Anyways, this takes a little bit for me to get through this whole talk. It kind of goes like this. You guys don't know packages, so I need to tell you, well, what was the problem we were having and why did we invent them? And then I'll talk about packages themselves, like, how did the solution go? What problems did we have? That sort of thing. Then I'll talk about modules, since I don't know how many people know about modules, but probably not all of you do. And then I can finally, near the end sometime, talk about packages and modules together and maybe how they would fit, if they would at all. So, packages. The problem of packages starts a really long time ago. It's about 15 years ago. PlayStation 2 is our default platform. With 32 megs of RAM was a lot of memory, and even back then, we had a lot of trouble sharing code. We had a lot of code to share, and everybody was duplicating it everywhere. It's easier to see and measure today, so I took a look at some current games we have, and 10 million lines of code, yeah, that's kind of about an average size of game at EA now. And we have maybe 20 games or so, 200 million lines of code, that would be hard. We don't want to be doing that. We don't want to be updating it, so we need to be sharing as much as possible. This is kind of obvious, even if it's a little tricky to measure all these things. So games may be different than a lot of other industries in the fact that we don't really control our platform. So, iPhone comes out and great, you're going to have to work on Macs. And, actually that's kind of wrong. PS2 came out and, we had to work on Linux for quite some time anyways. I think maybe PS3 we had to for a little bit too. Because of that kind of thing, we don't really have control of what environment we're going to be on. We made a build system that sort of works the way CMake does. It's kind of like a generator, and so you can make another build system from it. So how fast it runs and how fast it builds, it really depends on what build system we spit out. Most of the time, we build Visual Studio projects, and for better or for worse. And so this seeps into our vocabulary. Most of these platforms support Visual Studio, and so we call this step SLNgen, for example. So we also support a lot of compilers. Whatever the manufacturer of the console, the newest place to write your games on, Green Hills will come out for Wii U or something, and you'll just have to deal with that. To that end, we wrote little configuration packages as well, and so we could share these across with everybody and try and come up with a way of getting out as fast as we could our games on any particular platform. And making all of these compilers, as much as we can on the command line, look kind of the same. So, precompiled headers can work the same way in all of them. So, when you're building games, generally speaking, it kind of works like this. You download everything off of source control somehow or another. Usually all the data and the tools and everything comes here. And then you have to build the game. And by building the game, what I mean is you generate a Visual Studio solution, like, the solution files plus all the VC projects and everything to do with the package. And then you just call Visual Studio to build it, and then you make some very large executable, usually only one. Sometimes we have some DLLs, but and then after that we cook and we make all of our data, and the data is actually much bigger than all the rest. I'm not really going to talk too much about cooking today. It's quite an interesting problem. Sometimes it does have to do with packages on some teams, and most of the time it doesn't these days, though. But it is necessary for this to be done. And that every time you sync, you're going to have all of these things change, and so you're going to have to check dependencies on all of these things. And it just shows you sort of the scale of things and how much we're going to care about timing on each one, maybe. You're going to have to build more than you're going to have to generate solution, for example. So yes, 15 years ago, large amounts of code being duplicated. We actually had multiple build systems. Even on a single game team, you would have like one to build library A or library B, or for pre-built, you'd want to build all your libraries and then check them into source control so that not everybody had to build them, for example. You would have different systems for this, and each one would have its own build system. That was enough trouble on its own, but even 15 years ago, EA was a large company. We had, development going on in Madden down in Florida. We had, our headquarters is in California. Up in Vancouver, we work on FIFA and lots of other games. And the DICE studios were in Sweden, and they had the UK studios in Guildford. So all around the world, we had all of this development going on, and not everybody knew what was going on in all of the different studios. And we could see this, and so we wanted people to start to share. So at the time, the sort of new hotness was things like Ruby gems and C-span and those kind of things, and having a package server. And so we really thought this was going to be important. And so we wrote a system like that. And it was actually wildly successful. Soon games were made out of hundreds of these packages. We have thousands of supported packages on our servers. And of course, we run into another problem: how to deal with many, many packages. And so this was kind of where we are today. Basically, I'm going to talk about the solution of packages over a couple of questions here, like, do build systems really help? I'm going to tell you about something called Masterconfig, which I think was a stroke of genius that we had. And if there's any idea that maybe you could copy, this is probably the one. And then I'll talk about package servers and code divergence. And then I'll finally start talking about modules and things again. So everybody here is a C++ programmer, so you kind of know what you need to do to an interface in order to make sharing better. If you make things private and hide data, then it's going to be easier to share. If your library is just everything all inlined all the time, it's going to take longer to build and be a little harder to grab between various teams. So our build system kind of makes us think about this. And we have a concept for most packages by default will have a private directory for their headers and a public one. And so you only have to read the public one to understand its API. And the build system itself does the same thing. There's two main files to our build system. One is a global scope one, and one is a local scope, and they're effectively public and private. So what do one of these, packages look like? They're quite simple. They're not really that complicated. A good example here is ESTL. It's our STL library. It's just a directory full of files. So we start off with a directory, which is the name of the package. And then inside that, we'll have a version. And inside that, we'll have some public include directories. And in that, we usually specify the name of the package again, which is a bit odd, but if you think about it a bit, you want to make sure that your headers don't collide with one another, so at least naming it after the package means that vector doesn't collide with vector. That's a good idea. And then you'll have your source code and your private includes, and they will all go into a different directory. And that's pretty much it. Now, the version in the path is sometimes controversial. Why we do that is because on a team, you have many executables and you want some decoupling to allow yourself to have each executable to be maybe on a slightly different version of a library, so you don't have to upgrade everything all at once. Now, we don't necessarily need the version information in the path. There is ways of flattening it, and there's good reasons to flatten it as well. Like if you're wanting to use Perforce to integrate in a whole bunch of packages all at once, maybe you need to do that. But yes, this is why we have that version in the path. So the little domain-specific language that goes along with this, local scope and global scope, are the two main files for it. And each scope has its own file, and this is an example of one. You have to specify all the headers and all the CPPs, and for us, we usually just put ** in there and just recurse up the subdirectories. So it's kind of different than, say, like CMake or something. We don't really care about maybe how long our solution gen takes, I guess. And recursing up the tree means we can just about cut and paste these things into another directory and make a new package. It's quite quick to do. You have your private headers are also specified, and then dependencies. And dependencies are the things that you need to use, right? So I want the includes, or I want the linkage from here, I want the libraries from here. And linkage is transient, if you understand what I'm talking about there, and we don't do that with headers. You have to specify which ones you want. So now what do you get when you depend on something is basically depends on what's in its global scope. And say if you depended on LZMA, the compression library, you would get its includes and its libs, and that's it. It's quite simple, not really needing to specify much more. Now, if you had some plugin system or various other things, sometimes you need more information for this, but generally speaking, that's all you need. So, you can see that writing one of these things doesn't take you that long. Soon we had hundreds of them, and it was a pain to update them all. We ran into all sorts of interesting problems. It didn't really turn out as clean as my examples here. For example, when I talk about the names of packages and depending on things, we started with syntax like this one, where you had to depend on a package and then specify a whole version of it, right in line. And of course that didn't work very well because, you upgrade Visual Studio, once a year. So then we started going, maybe we needed ranges, and well, that didn't work very well either. It was all really repetitive. This is just this section here, right? Where right now I just list a list of packages, but previously I would have to specify information like that. So why is it bad for it to have version information in the path well, everybody's going to have a package like this one, maybe. This is a library, it's a header-only library which detects the compiler features. We take a look at the version of the compiler and then we'll know what level and what support of what features we are allowed. It's called EA base. And so nearly every package in EA depends on EA base, so it's really highly used. So if you put the versioning information inside each package, you're going to have a problem. You're not going to want to update this thing. It goes on for quite some time for this. It's just crazy. If you're replacing across the whole thing and then have to check in all these files, you're asking for trouble, even for a simple upgrade, let alone a complicated one. So we removed that information and we did what anybody would have done. We put it in a separate file. We put it in one global file that is shared across a whole team, and we called this the Masterconfig. All this file has is very simple. It's just the name of the package and a version number, name of package, version number, one to one. You're not allowed to have more than one version of the same package. That's just not allowed. You try in Solution Gen, it doesn't work. And that meant, at this point, all we had to do now is open up our Masterconfig, change a version number, as long as it built, check it in, and you were done. That was really easy now to do simple version changes. But package upgrades are rarely simple. They often take time. And if everybody's changing them, you had hundreds of packages. If you just sort of think about it for a bit, you're maybe doing one or two a day. This file ended up being like every time you sync it, you'd have to resolve conflicts with it all the time. And that was problematic. So one thing we did to help solve this problem was we added some variables so that when you were generating solution, you could go, okay, if I want to switch to the new Visual Studio 2017, you just pass in another parameter. Visual Studio 2017 is enabled. Everybody else in the project could still use the old default one. The default one would be there, 2015. If you didn't pass anything in, you'd get that one. So you don't have to affect anybody. But you could check in your changes that you're going to do. Roughly speaking, I'm going to need these packages. It could even be broken for you. But I'm going to need a change like this in this file and check it in. So you could get rid of the conflicts as quickly as you can. I think now it's kind of interesting to sort of take a step back and see what we had now. If we compared ourselves to, Python or Ruby. I'm not much of a Python or Ruby expert, actually, but I think this helps a little bit just in case people in the audience know this a little better. We had a package server now. We could put all of our content up on that. It was private to EA, which is unfortunate, but it kind of works similar to like Ruby Gems or PyPy or something like that. If you install the package, you would install that and all of its children, and then you could use it in the environment in Python or in Ruby. And that's really cool. The one that we had is a little bit different. We can you'd have to have a master config somehow or another, and then you would generate solution. And if it was the right type of master config, then it would download all of the package necessary. So if you generate solution for a movie player, let's say, then the movie player, the file I/O library, the rendering library, and the audio library would all come down, and it would build you, say, an example movie player there. And that was really good. This is kind of similar. The other thing that we could do in a similar sort of way is, let's say the movie player, mostly what you use it for is just playing movies back and that kind of content. So maybe it doesn't matter that it's on a really old version of DirectX. So running DirectX 9, that's fine. It doesn't matter. You can just, in your master config, then say, okay, if I'm building the movie player, DirectX equals version 9. But if I'm building the game, I want to run on DirectX 11 or DirectX 12, so I can specify that. So that's like environments and gem sets. Now, like I was even explaining in the previous example, you can kind of implement like virtual environments with the same thing. You have this master config there, and you can just have a switch there that goes, okay, I want to use the latest version of Visual Studio, and you can switch between platforms and things in a similar sort of way. So now that I look at it and I understand this stuff a little bit better, I think what we've done is we've implemented something pretty close to lock files. Lock files are usually a generated thing, and ours are hard-coded, but it's maybe a bit simpler as well. But they're quite similar in feature set, really. I want to talk to you a little bit about an example of how this ends up working at the large scale and what we're able to do here. What happens a lot is you need to upgrade some large piece of technology, say, for example, a new rendering engine. So, of course, what you can do right away is you can just change the master config, add some new variable in that goes, okay, well, I'm going to need these packages. It doesn't really even build much yet, but that you can set it up so you can have a small team of people working on this for 6 months or a year or something, because it's going to take you quite a while, obviously, to put together a whole rendering engine. You're going to want to make sure that you have all the full feature set of the previous one, and you're going to want to meet APIs and stuff and have it be the same way. The people that use the old rendering library, they're all fine. They're all still using the old rendering library. They haven't had to change at all. But you can stay in the same branch here. You could stay all working in the same branch if you wanted to. It's kind of like branching on individual packages, nearly like submodules in Git or something. So this is a really powerful way of thinking of things, and you can look at it at a high level and see what's going on just by taking a look at this master config and see what's changing in the whole game. And you can do this in reverse as well. So it's not just for like new technology when you're inventing new technology and you've got this smart group of engineers working on that. You can use it for older technology. You're like, oh, well, the rendering guys, they haven't quite finished writing their new particle system GUI or something like that, but I need content for it. Well, maybe we can just keep that old renderer running for a little bit and use that GUI from there, and it'll all be good. We can make the content and then write an exporter to the new one. And the new one's what we're going to ship to the customer, but we can use the old tools to make the new data. And that's okay. And it takes us a little while, but after that point, you can finally remove these old libraries away. Now, I think this really only works when the teams are kind of lopsided. You've got 150 people on the default version, and you've got 10 people on the new version of the code or something like that. Then it works pretty well because you don't want everybody to have to change the way they work and to test both environments all the time. That's really difficult and takes more time. Really, what you want for, say, the new rendering library is to communicate, oh, we need this new feature. So, if they get broken a little bit, it's okay. They're probably the experts in writing this API anyways. They need to have that conversation, and they need to know about the fact that the main team needs to write this new feature, and as far as they know, they need to break the API here. I mean, maybe they'll have a conversation, they'll be able to get around it, I don't know, but that's the idea. If the teams are exactly equal size, probably I would branch. But it is a nice in-between land. So, can packages actually help, or do they just get in your way? If you have, if your build system helps you specify what is public and what is private, I think it can help you. Also, standardizing, the way you work across a company the size of EA is really valuable stuff. Masterconfig, I think, was kind of a stroke of genius for us. It really helped us, deal with the problem of libraries at a higher level, and this was quite useful. So now I'm going to talk a little bit about package servers and code divergence. So package servers were really invented to try and tell everybody about a new package and what was going on here, and automatically download all these things. We could see it in Ruby and these other languages that this was a really cool idea, but it's kind of a bit odd when it comes to doing it on a whole game. This doesn't really make any sense, right? You're not going to genus-lend FIFA and have it download all of the packages from FIFA. At some point, you have to stop. It's not a versioning control system. It's kind of an advertising system for like low-level packages that you think are curated and good to share. So, if you only have one of these across your whole company, you probably don't need to put it there. It's a place to find and try out low-level packages and test them. All we do to put things up on our package server is we just take that directory structure, zip it up, and put it on the server. There's nothing else. Like that's the whole steps there. You obviously you need a master config to go along with your tests, and so one thing we had to do is duplicate this versioning information again. But we didn't really want to do that. So what we did to handle that particular problem was all the library teams roughly worked on one set of packages and they just cut and pasted across them all. So they over-specified how many packages and dependencies they had, but that seemed to work pretty well. This didn't scale very well for the game teams, though. They didn't post everything to the system. And there's other interesting problems around outsourcers and things, but I'm not going to talk about them too much today. But you can just think of, don't put your latest version of Star Wars on a public server with 10,000 people or something before a movie comes out. That would be a bad idea. Version control systems. This is really what we do, is we post everything we can to our version control. Tools, data, libraries, everything we can. And sometimes we're not allowed to put some things there. You can't, export controls across country boundaries and things. But and in those cases, we'll make something called a proxy package. But there is ways. But generally speaking, as much as we can, we'll post everything onto our servers, and we'll sync and we'll build. And this will work great for game teams. Our library teams, though, have a really big problem here. The problem is every single game team will just upgrade willy-nilly. They'll, they have their own reasons to upgrade. They need a new rendering engine. They need a new audio thing. They need new file I/O performance. But if you're writing a movie player, what are you going to do? You need to write to a standard API. You need to know what's going on. The only thing we could figure out what to do is to force everybody onto some version and then track them. Make sure that, we knew how many lines of code they were divergent. And this worked pretty well, that we'd also then find out about, bug fixes and cool ideas like that. And this change is actually really necessary. Or have the conversation with them that, oh, yeah, no, you don't want to be doing it that way. You can fix it this way instead. Because the game teams understand the problem, but the library teams understand where the solution goes and how to write the solution. But this was only actually in sports. Dragon Age and Mass Effect, Need for Speed, Battlefield, all of these kind of people were solving this similar kind of issue with Frostbite. They built up a huge stack of technology, and then they just integrated that across all the various studios. And that's how they would solve this problem. Today, we're mixing the two together, and this is actually one thing that Igor worked quite a bit on, is moving Frostbite to packages. And we're trying to improve all this technology as we go along now. So, package servers, really useful for low-level leaf packages, not really used for whole games. Divergence is a really hard problem. The best that we know how to do is just to have a stack of technology. And you can see this in all the game companies now, and that nearly all of them are basically based on an engine. And they all have like one version to write all their code against. Okay, finally, we're starting to talk about modules. Excellent. All right, so packages, you can see that there's these kind of those library things. Modules, on the other hand, they're trying to improve build times, right? They're better separation between interface and implementation. And really, hopefully, there's some viable way of moving forward with these and for existing libraries. And that's kind of why I wanted to take a look at it, is to see how viable is it going to be for us to move forward. So, of course, everybody here is a C++ programmer. You guys all know CPP files make object files. You probably know that .h files make PCH files. This is the kind of difference, though, is this idea of modules anyway. There's kind of a one-to-one relationship here for the modules. And modules are going to be called .ixx's, and they're going to spit out an IFC and an object file, in the case of Visual Studio anyways. The names of these things are changing all the time. Clang has its own naming convention. It's kind of interesting. I like the Clang ones, actually. A good naming convention for them. But anyways, I'm going to talk about it from Visual Studio's point of view, since that was the farther ahead thing for the modules TS. So, to give an example of how modules are supposed to work, I had to write a little tiny example, and that's what I'm going to do here. I have 3 files. I have main.cpp, mimpl, and a module. So I just have a simple class called miin_interface, and I implement it, and I have the interface defined in module. The thing is, though, is the command lines are not necessarily stable yet, and there's a few different ways of working. And so I decided to implement them both because I thought it was quite interesting, both of them really. If you use these things called references, you have to refer to individual packages, individual files. And if you use search paths, then the name of your file needs to be the same as the content inside it. It'll be easier if I just go along, I think. So this is what a module looks like. And this module can have one of 2 names. It can be mi.ixx, or it can be just capital M.ixx. And you can write a bunch of stuff at the top and include things. And this is all private to the module and won't be expanded to other things. And then you can say that you've got a module, and then you can export some stuff. And so I think these modules will be useful because they can make things private and public. And that's a good idea. We know this. But yeah, I didn't worry about that. Okay. So this is what the command line differences look like. Don't worry about all the stuff in gray. I mean, that's just to make sure you guys know how to get it to actually work. The main thing that I had to specify that's different between the 2 ways of working, between search paths and references, is just different, output names. So that's all I'm talking about here. When you use one of these modules, this is where the interesting stuff happens on the command line, is you just import it. And then you have all of the public interface there. And that's simple. It's just like including a library. And then you can write your functions that had to do with that namespace. And there you're done. That's pretty simple. But so here's how you use that. Is on the command line, you will need to either specify the reference to your IFC file. This is the output that you built out. You'll need a reference to that. And when the export happens, it'll then find out that inside this file there's an M. So when you import in M, it goes, okay, check all my references. There's my M. Excellent. And import that. And if it doesn't find one, it gives you an error. In the search path, it's kind of the same thing, except you just give a directory of stuff and it goes and, okay, is there a file named M? Okay, yes, there is. Now I look inside it and yes, there's a thing called M inside. Excellent. Then if that all works out, you don't get an error. Excellent. So main.cpp, it's using it as well. So the command line is the same. There's no changes here. You either have to reference your module or you have to search for your module. Excellent. Linking doesn't change at all. You have object files. You had object files before. You have object files now. Nothing changed. Okay, probably 45 minutes in or something like that. And finally talking about packages and modules. Excellent. So what I would actually think we would do here is If we were using search paths and we had our package technology, we would probably just have these search paths as being just like our include paths. So in our global scopes, our public interfaces of our packages, we would just list, okay, these are the new search paths for modules that I would want to use. And that would work out pretty well. It's similar limitations to header files today. References are a bit more interesting because we don't really have the equivalent of them. So I could list out all of the, I guess, modules for this package, since there could be more than one module per package, but I think this might lead to an interesting problem. So you see, modules can't have circular references, and EA packages can, at least at link. Headers themselves, don't have circular dependencies. We already had to disconnect all of these things, right? But what I'm worried about is if one package equals one module, or basically the same meaning would be one package equals all of the modules, which is probably what I would have to specify in my build system. This might be difficult and would lead me to an interesting problem. And this problem, just to give you a feel of it, is the problem you run into every once in a while when you're using a single path linker like GCC, and you're like, oh, yeah, why do I need to specify this library again to fix this error? It's just because, the linker only links one direction and it's single pass and stuff like that. And maybe you solved it like that, or maybe you did what we did, which was, yeah, we just put all of our libraries in one big start group, end group, and keep looping around until you're done. Lovely. Works great, I guess. It's the default in Visual Studio. How could it be wrong? Yeah. Anyway, so the next ones, if you understand makefiles, will be clear, and if not, you're going to be a bit confused. Basically, in a makefile, you have output : input, and if you change one of the input files, then you're supposed to build the output, and the line that you will use is the line below. So that's kind of what I'm trying to explain here. So there's command line options for the compiler to generate dependencies, and they can generate little files for you and stuff, and they don't have the equivalents of these right now for modules, and therefore I don't really know how maybe you're supposed to make this work. So the thing here is, say I had application.ixx here, and then it imports rm. Now, how do you know that rm equals rendering.ixx? I don't really understand how I'm supposed to figure that out. I guess I can make some kind of global table or something out of it. I don't really quite understand. I'm sure there's some good thoughts involved in here, but I didn't know what they were, so I thought they were a bit odd. But if I use search paths, on the other hand, I can tell. I would be, importing in rm, and there would be an rm.ixx somewhere. I could figure out what directory it was from, and therefore I could figure out, okay, probably the output would go here, and I could figure out how everything was going to work together and that dependency. So, anyways, so that's kind of interesting. Modules at scale. Modules have different rules than .h files or object files for naming. I mean, object files are kind of private to a module or private to a package anyway, so they're kind of just a different beast. But .h files are a little similar. .h files have paths though, and modules don't. So that's a bit interesting. I'm not sure why they made that choice. EA has had trouble with package naming in the past and trying to get their headers not to collide. So if you have FIFA vector and ESTL vector, and you depend on both of them, you're in trouble if they just are called vector, right? So probably if we were to use modules, I would look at it and we would just go package name dot module name dot ifc under dependencies. You can kind of clear this out as much as you can by making sure that your packages don't, just don't have like one global list of all of the headers that they need for all packages, all your libraries, right? if this library only uses FIFA vector, then it only depends on that. It only gets those headers. And if this package only uses ESTL vectors, well, great, it only uses that. But that only fixed 80% of the problem. You're still going to have like high-level modules that try to initialize everything, and they're going to depend on nearly everything. So that's kind of a bit of a problem. One other thing I noticed in Visual Studio 2017 is if I had like an inline function in a module, and then I had another version of it in a CPP file, exactly the same content or different content either way, just the same function though, same specification, it wouldn't give me an error. Clang did, but Visual Studio would not, and so that was kind of interesting. The inline one would always have priority, so the one in the module would always win. I don't know why. So Clang has trouble with legacy headers and macros and things. I don't know really too much about it. I think there's other people that have been talking about it, and I'm probably running out of time anyways. So let me just summarize this whole talk up one more last time here. So modules, they're a better version of a .h file, right? They're called .ixx or .cppm. They could use, some way of, creating dependencies, so we could see maybe how you're supposed to write a build system for them. That would be a bit interesting, just to prove that we can. So in EA, I think if we started using this at scale, we might run into a problem around circular linkage. I'm not really sure, but possibly. Name collision certainly would be a small hindrance anyways. But if we're careful, it wouldn't be too bad. Would I use modules in production? Probably not. We have too many platforms that just don't support this today. It's kind of a toy project that we should be looking at and just make sure that it's going the right way for us. So, summarizing things up. Build systems. Are they useful? Well, if they get you to hide the appropriate things, then yes. If they standardize the way you work, yes. Masterconfig, it was a really good idea. Having one versioning file across a bunch of executables, one versioning for the whole team was really valuable. Package servers, they are a really good idea, but they're really only about low-level packages. If I was working in a small company or something like that, I don't think I would, think it's the first thing I would write. But in a big company like EA, it's quite useful because you can find out, the latest version of each of the packages and those kinds of things. Finally, mitigating divergences between teams. This is a very hard problem. I guess you can just force it top down and just say you're going to use those versions. I don't know, it's quite difficult. And one last time through modules. Better version of headers. There's two ways of using the command lines at the moment in Visual Studio 2017, by search path and by reference. I don't know which one's going to be standard, so should both. No way to generate dependencies yet, and maybe we have some problems with circular dependencies. And that is everything. Thank you. Yeah. Cool. I guess there's a microphone over there if anyone's got any questions or anything. Or I can try and repeat them or something. Yeah, probably better. I mean, I can try and repeat them as well, but I guess that's a professional thing for me to be doing.
So I have I have two-part question, I suppose. Yeah. Have you shared this with the module's TS authors and so forth? Like your opinions on all this?
Not really. This is kind of, hey, surprise.
So I've been somewhat involved in this process, and the circular linkage one, I think that one is not super controversial in the committee. Like, I think you're going to lose that fight.
Okay.
But it's something we should bring up. The other one that was more interesting, it's actually a source of some amount of controversy, at least historically, which is this whole idea of like, how do I name these things? How do I deal with name collisions? What's the identifier?
Yeah.
So your like large scale deployment experience might actually be useful in like helping settle some of this.
Cool.
So I'm not asking you to write a paper, that's a lot of work, but at least that would be good if you could do that. But at least sharing it with the people at
Yeah, I was hoping that this would cause me some discussion here, and I was hoping to talk to some of the experts. I don't know if any of them showed up.
Do you know Gabby Dos Reyes?
I do know him a little bit. I messaged him, and
you should
nothing
corner
came
him.
back, and
He's here somewhere.
I will try to corner him again. I cornered him last time, and so so it'll be good to try and talk to him again. So yeah, thanks. Anybody else?
So I'm kind of coming from other languages like Rust and ML.
Yeah.
And I don't really get the point of these modules. Like, they feel kind of like precompiled headers.
They are.
So
They're just about making things build faster.
I mean, like, why not just use precompiled headers is kind of my idea.
Though at least the relationship between them is a bit different, right? Like there's a many-to-one relationship there, and so you'd only have one precompiled header per package in our case, right? So this would be able to divide it up in a slightly smaller unit, I guess. I mean, whether that's enough performance gain to make it worthwhile, I don't know.
I look at like languages like Rust, and Rust doesn't have the best module system ever, but it's just like, it feels a lot more like actually in the language, as opposed to this, which feels very much like, well, a preprocessor thing, basically. And I just wanted to think, like, what's your opinion on that?
I mean, is modules just a preprocessor thing? Maybe it is. I mean, to me, this is one reason why I kind of did this talk, is because I felt like we weren't quite taking it far enough. We want something more like packages at EA, I think.
Yeah.
Where, I've had this for 15 years. I don't see this as being that technically difficult. What's harder is to get everybody to agree.
Yeah.
And if you look at Google or something like that, they have more than one build system. And they're really good engineers. Like, they're not, there's a reason why they're probably doing that. I don't know what it is, but I'm sure internally they have this discussion all the time. But getting us all to agree on one seems to be quite difficult, and I don't know why.
All right.
Not quite yet.
Hi, do you use this package system only for source-based packages, or you can distribute binary pre-built packages across teams? For instance, ESTL, maybe it would have already lib and DLL files pre-built, and user will have it linked only without need to recompile everything?
So what you're asking for is, do we just use these for source-level libraries? And the quick answer to that is, basically, we only use them for source-level libraries. We can use them for binary information, but the complicated answer is, we actually use them for a crazy amount of things. We can use them for tools. We use them for data for some teams. We can use them for all sorts of stuff. So anything that you could version, in theory, you could put into one. It's kind of like asking the question, what could you use Git submodules for? A lot of stuff, actually. Yeah.
Thank you.
We use it for a lot. Yeah.
So my question actually builds on top of that as well. If you're using it for binary packages, then how do you get around the linkage and using the same flags? Because otherwise, it would not link.
Okay, so how do we get around the linkage problem?
Like, right, because you kind of glanced over that.
Build options, and every team in EA has their own build options, and this is one reason why we're basically source level compatible for the most part. So there are some libraries that we have to distribute like this, and say the third-party libraries or something like that, and then we will actually have libraries internally in them, and then they're a pain in the ass. They're hard, and somebody has to, oh my gosh, we've upgraded compilers, rebuild it, and then distribute it for everybody, and it's kind of a pain. Source level compatibility is much easier for that sort of thing. I guess that's where we are. Yeah.
And with the current source level compatibility, do you specify the linkage flags or the compiler flags on the very top, kind of like on the master config, and then it kind of transients into the all of the packages?
Yeah, it's a little more complicated than that. We have a thing called a configuration package, and the configuration packages specifies this. So each compiler kind of has their own one. And then on top of that, we'll actually have something called an EA config. And then each team configures their own on top of that. But generally, that's like it's one version of all of that information. So there's only one way to link usually across a bunch of things, and we will specify options on the command line to change how we build.
Okay, thank you.
Do you feel like that this is something only valuable for like the scale that EA works at, or like a smaller studio that's only working on 1 or 2 games? Is there any value to doing package management there?
If I was in a smaller studio, would I do something like this? I don't know if I would have a package server right away. I might avoid that, but having a standardized build system, certainly I would look at. If I could force the concept of public and private headers, I would try. There is disadvantages to doing that though, and I would like to see if we could figure out our numbers for them. Like, think about it, we have 100 packages. You have one dependency, 100 packages. Now you have 100 search paths for these things. How expensive is that? How good is the OS at caching? It's kind of an interesting question. Seems like it's not so bad, but I bet you there is some cost.
Also, your master config, once you start adding parameters, it sounds a lot like a make file at a certain point.
No.
No? Okay.
It just has packages and versions. It doesn't end up like a makefile at all. It doesn't have any dependency information or anything like that. It's just if statements and packages and versions. That's pretty much it.
Hey, 2 questions. So you mentioned you have very large number of packages, right? So just out of curiosity, how many packages you have which can parse XML? That's the first question.
How many packages can parse XML? Excellent question. I have no idea. It's got to be at least 7, maybe 10, probably more. I don't know. Like a lot.
Right.
And
So
everybody uses their own. In just FIFA, I'm sure I must have 5.
that's good, yeah. So second question to follow up on this. So EA is a massive organization, right? So say I'm developing a package.
Yeah.
How do I broadcast new release? Because I can't just email to everyone. That's too big.
I could just put it on a server. As I said, you could any individual SE at EA can just take a directory, zip it up, and post it to the server. And I don't think there's any security on this thing at all. Like, you just post there. That's how you post a package. It's really trivial.
Yeah, well, it's not about security. It's say I develop new package.
Yeah.
So again, do I send an email to everyone saying, look, that's a great package. This is what it does. So how do you promote it, and how EA deals with like duplication?
How do you promote a new package? I think it would depend on the package. It's kind of like, how do you market a new product? If you have a good product and you think it's worth selling, then you would have to find the right channels to market it, depending on who you want to talk to. You could send it to all the programmers at EA. There's kind of a mailing list for that. But I think if I could target it towards the people that might actually care, that would probably get you more hits. That's probably how I would do it in an organization like FIFA. We have lots of channels for communication, like Slack, and we have channels, various mailing lists and things like that, and significant SIG groups, significant interest groups, or stuff like that. So if you talked on those channels, that's what you get.
So do you reward people internally when they contribute to to packages?
Yes. Do we reward people for doing packages? Yes, we do. It's an interesting problem of whether you should. It's like one of those questions. How do you tell if a programmer is a really good programmer? How efficient are they? If you tell every engineer that they're supposed to support some major piece of technology, they will try very hard to support a major piece of technology. Whether they should or not, it might be better that there was only one of them. But if you reward them for it, they will do it. So it's a mixed problem there. Yeah.
All right, thank you.
Hi, I have a question about how you are going to support multi-platform. Because every game you have different platform need to support, and each platform has independent code, for example. Yes, so if you put in all package, it might be like mess up. But if you put in separate package, it would increase the amount of package you have. So how EA treat this kind of situation?
generally speaking, how do we treat packages? Are packages sort of platform independent or platform dependent? And it depends on the package. Most packages handle this themselves. And so you'll have a rendering engine and it will hide the fact that it's dealing with multiple platforms with the code underneath it. So I showed an example there that just had like source code ** CPP. In there, you can actually put a bunch of if statements, and then you would go, if it is PS4, grab these files. If it's, Xbox, grab those files, kind of thing. And then the package itself would change based on that. And there'll be, like, if you need to do it within a file, there'll be if-defs that you could use across things as well.
Thank you.
Okay. All right. Guess that's it. Thank you very much.